If you're here, you're one of the future pioneers of AI engineering. My name is Mel, and I get to work with the absolute leaders in architecture, engineering, and construction. And today, we're going to explore what I truly believe is the next great frontier. So let's start with the big question, the one that I think is the defining challenge of your generation. It's not just about building taller skyscrapers or longer bridges anymore. The real challenge is managing the immense, almost overwhelming complexity of our entire built environment from the very first concept all the way through its entire operational life. Now, to meet a grand challenge like that, we need more than just static blueprints or old school 3D models. We need a whole new vision. We need a living, breathing, intelligent, and predictive virtual replica of our world, and that is what a high fidelity digital twin is all about. This isn't just a pretty 3D model you can spin around on a screen. No way. This is a live simulated world that mirrors, predicts, and even interacts with its physical counterpart. It's powered by real time data and it's supercharged with AI. Think of it like this: we're moving from a static photograph to a live video feed of reality, but a feed that can also show you the future. This table really lays out the fundamental shift we're talking about. We're making a massive leap from traditional building information modeling, or BIM. You know what I'm talking about: static, disconnected files, data that's siloed off in a dozen different formats. We're moving to a live synchronized ecosystem that's all connected through a universal language for 3D worlds called OpenUSD. This isn't just a simple upgrade, it's a completely new paradigm. So the big question is, how do we build this thing? Well, it all starts with perception. We have to capture our physical world with an accuracy that was just impossible before. This is the very first layer of our stack. This is how we give the twin its eyes to see, and this is where AI is quite literally changing the entire game. For years, we've relied on photogrammetry and LiDAR, and they're good. Don't get me wrong, but they have their limits. Photogrammetry, for instance, has a really hard time with shiny reflective surfaces. And LiDAR, while it's great for geometric accuracy, it doesn't give you much texture detail. But now we have AI techniques like neural radiance fields, or NERFs, and Gaussian splatting. These methods create digital representations that are so much richer, so much more context aware. They capture not just the building, but the world around it. And this is where our tools come into play. Take Neuralangelo, for example. It can take a simple 2D video from a phone, from a drone, whatever, and transform it into an incredibly detailed 3D structure. And what makes this possible is the sheer horsepower, the massive parallel processing power of NVIDIA's RTX GPUs. So if the AI-powered reality capture is the eyes of the digital twin, you can think of NVIDIA's RTX GPUs as the visual cortex, processing all of that information at unbelievable speeds. And look, this isn't just us talking theory in a lab. Construction technologists like Ben Stocker over at Skender, they're seeing this in action. He found that because these new methods capture the full context, you're not just seeing the building, you're seeing the cityscape from the balcony, you're seeing the traffic signs on the street below, and that full context, that's what enables smarter, faster decisions on a real active job site. Okay, so let's move up the stack. Our twin has eyes. It can see the world in incredible detail, but now it needs a body. It needs a place to live, to breathe, and to operate according to the laws of physics. It needs a world, and that place is NVIDIA Omniverse. You can think of Omniverse as the digital twin's central nervous system. First, it connects and unifies all your 3D data from Revit, from AutoCAD. It doesn't matter what tool you use, all through that common language, OpenUSD. Then it simulates reality with physically accurate real-time RTX rendering. And this creates the ultimate sandbox, a place where you, the researchers, can truly develop and test what comes next. And that's exactly why Omniverse has become the core engine, the operating system, really, for industrial digital twins. It's the platform trusted by pioneers like Siemens for factory automation, the incredible Zaha Hadid architects for their groundbreaking designs, and even Microsoft for their enterprise scale solutions. Okay, now we get to the most exciting part, in my opinion. We've built the eyes to see the world. We've built the body for it to live in. Now we give the digital twin a brain. We give it the ability to perceive, to reason, and to actually act within its simulated world. This, my friends, is physical AI. So how do we build this brain? Well, we use platforms like NVIDIA Metropolis to create AI agents that can, say, monitor a factory floor for safety compliance. We use Isaac Sim to train and test robots in a virtual world millions and millions of times before a single physical robot is ever deployed. But the real breakthrough here, especially for your research, is our Cosmos Reason model. This is what gives agents physical common sense, a deep understanding of space, time, and physics. It's the secret sauce. So, what does all this look like in the real world? What's the payoff? Well, the electronics manufacturer Pegatron put a visual AI agent built on this exact stack to work monitoring their assembly lines. The result? A staggering 67% decrease in defect rates. I mean, think about that impact. And over at Siemens, they're empowering their shop floor workers with something they call an industrial co-pilot. It's an AI assistant built on this very same stack that helps them troubleshoot problems on the fly, and it's reduced their reactive maintenance time by 25%. This is where your research into AI agents becomes a reality that boosts productivity and, more importantly, safety. So let's just recap for a second. This entire end-to-end stack, from perception with reality capture to simulation in Omniverse, all the way to reasoning with physical AI. This is not some distant, far off vision. It's here today, and honestly, it's built for researchers and pioneers just like you to take it and push it even further. And we're not just going to show you all this cool tech and say good luck. We've laid the foundation and we've provided the tools we want you to build on this platform. You can start right now. Learn the fundamentals with free courses from our Deep Learning Institute. Head over to GitHub and experiment with the very models we've been talking about, and then use our Omniverse SDK to build your unique vision. Look, we are standing at the edge of a brand new frontier in AI engineering, and this is an invitation to you, the next generation of thinkers, of builders, of creators, to join this expedition with us. The platform is ready. The challenge is set. The only remaining question is, what will you